Greetings and welcome to the Chemistry 223 Qualitative Analysis of Group 1 Cations Lab Overview. You can probably see why a lot of times I abbreviate it QA1, but anyway, this lab will be a lot of fun compared to a lot of the labs we've done recently because, first of all, there's no math. Wah, 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 I know. Anyway, a lot of chemistry, of course, depends on math, so I'm not saying math is bad. However, it is kind of fun then to have a lab which is all based on experiments and seeing colors precipitate, stuff like that. So QA1 is a lot different. I think you'll enjoy it. The most important thing is I want you to be safe. So it's going to be safety glasses all the time. Don't wear sandals. Don't wear shorts. Don't wear shirts where your midriff is exposed because I'd hate for there to be a spill and it get on you or something like that. So just FYI about that. Let's talk about QA1 a little bit. In the QA1, Qualitative Analysis of Group 1 Cations Lab, we're basically going to be looking at ways to separate the silver plus, lead 2 plus, and mercury 2 plus ions. And historically, these have been called the group 1 cations. They have similar reactivity. And if you remember from Chemistry 221 or so, all three of those react the same when it comes to chloride, bromide, and iodide ions. So while chloride, bromide, and iodide don't react very well with most things, they just stay aqueous. With lead 2 plus, the silver plus, and that wild mercury 2 plus ion, they do make insoluble compounds. So if you add a source of chloride, i.e. hydrochloric acid, or even sodium chloride, all of them will form precipitates. And this is a way historically that those three ions were separated from all the other ions that are known, which is kind of a cool thing to know. You could have also used bromide and iodide salts or acid, stuff like that. Honestly, hydrochloric acid is just a cheaper thing for us to have, so that's why we do it. But there are options available, and again, can be used to separate those three ions. So what you want to do in this lab is, first of all, you want to separate those three group 1 cation labs from anything else. If you go like scoop up a source of water, for example, it might have those three ions in there, but it might have magnesium or manganese or something like that. So you want to separate the group 1 cations from everything else, and that's usually with a chloride source. Once you have the three ions separate from everything else, then you want to start separating them from each other. And the first thing you're going to do is separate the lead from the silver and the mercury. Lead actually is soluble at hot temperatures, while silver and mercury chlorides are not. So the lead chloride can be separated that way, and you'll have the other two. Finally, then you'll separate the silver from the mercury. And once you have these things separated, you need to make sure they're actually there. So there will be a confirmation test, like a yes and a no test, to make sure that they're actually present. And so in this lab, there's no math, as I said, but you will be graded on the accuracy, i.e. do you have these ions? Do you not? You will be granted a unknown with between 1 and 3 of the group 3 cations, and your goal is just to tell me what exactly is inside it. A flowchart is very helpful when it comes to these different analysis of the group 1 and other group cations. And a flowchart is just a way to kind of show how you're going to separate it out. So the first thing you want to do, if you look at this sample flowchart I just found on the web, is you want to get the three cations away from everything else. So if you add hydrochloric acid, then that'll get the three group 1 cations, the silver, the lead, and the mercury, away from everything else. It says supernatant. Supernatant is a fancy word for liquid over the solid. So that liquid over the solid supernatant would have all the other ions possibly inside it. Then if you heat it up, you'll separate the lead from the silver and the mercury. You'll then add some ammonia. If you look at the steps, you'll get the mercury away from the silver. And then finally, there'll be a confirmation to see that you actually have the silver, yes or no, the mercury, yes or no, and the lead, yes or no. Now, this flowchart is not perfect. For silver, if you look at the bottom in the middle, it shows like a yes and a no. And if you see a white solid, that confirms you have silver. If you don't see a white solid, then you don't have silver. So that's like the yes-no part. This flowchart only shows yes answers basically for lead and mercury. So I would encourage you then to have a yes-no part for both the lead and the mercury. If there's any questions about that, let me know. Now you'll be creating a flowchart for this lab. It's not difficult. Hand-drawn versions are fantastic. If you want to go fancy on the computer, that's great too, but honestly, just a hand-drawn one is fine. But it'll look something like this, all right? Not a lot of words, more a lot of visual kind of aspects as to how you separate them out. There's some new lab techniques we're going to use in this lab and also the QA3 lab in the following week. The first one is called a centrifuge. A centrifuge is a device that spins a sample around and around and around really quickly. And by doing that, gravity pulls the solids to the bottom of your tube, and the liquid, the parts that aren't solids, then stay above. And that's a pretty cool kind of thing. Centrifuges are something you might have seen in movies. Just kind of realize it. Now, in a centrifuge, it's really important to have a balanced spinning motion. So you always want to centrifuge two samples at the same time, and they should be like opposite, like 12 o'clock and 6 o'clock, or left and right, if you will. You don't want to have just one sample by itself, because then your centrifuge will go crazy. So anyway, always do two samples. You can use just water if you want, but they should be approximately the same volume / same mass and stuff. That's kind of the idea. Decanting is a way to get that supernatant, the liquid over the solid, away from the majority of the solid. Now, decanting is not really a very quantitative technique. It's not about exclusively getting all the solid from the liquid. Like, we're not filtering it. But the advantage of decanting is that it's very, very fast. If you're very gentle, you can pour the liquid off, leaving most of the solid in the original container, and then the liquid, that supernatant, may have other things you want to analyze too. So remember, in decanting, the goal is to get most of the solid away from most of the liquid. But if a little bit is in either one, it's okay. We're going to be heating samples. In QA1, you'll be actually taking a beaker and heating it with water and then placing the sample inside there. Watch your samples. You never want to get a sample totally dry, because that'll then cause solids to form and it'll mess up your things. And the hot plates can get pretty warm, so just kind of FYI. So you want to gently heat them, pay attention, don't start texting and stuff like that, or else you will seriously have some issues. And another technique we're going to use is the use of pH paper. Now, on the left-hand side there, that shows one version of pH paper that we use. pH paper usually comes in long rectangular strips, and what you want to do is cut those strips into 4 or 5 little pieces and place them on a watch glass. Then if you dip with a stirring rod, your stirring rod into your solution that you want to test, and then touch a piece of paper, the pH paper will turn one of the colors you can see on that little container. Generally, red and orange are seen as very acidic. Green and blue are seen as basic. So usually these tests are just to know if you're acidic or basic. So if you're red or orange, you're definitely acidic. Green and blue, definitely basic. Anyway, I'll show you examples using all these things in a video here pretty soon, but this will give you a heads up as to what's going on. In this lab, you want to analyze a known sample which has all 3 of the cations in it, and you'll make this up by adding 6 or 7 drops of each one of them to a test tube. And you're going to analyze your unknown at the same time. And the advantage of this, first of all, besides just saving time, is your known will always have a positive result. So if it says if silver is present, you'll see a yellow solid. You should see a yellow solid for your known. Your unknown may or may not have lead, so you may or may not see yellow solids and stuff like that. But your known, at least, will always have a positive result, so you know what to expect. Safety goggles, super important. Don't even think about taking them off during this lab. We have so many chemicals running around, it just gets kind of crazy, so make sure you have it. Again, your safety is really important, so I do not want you to wear open-toed shoes like sandals and Tevas, stuff like that. If you wear a shirt that exposes your stomach, I won't be happy about that either, so just be really careful. All right, don't wear shorts. All right, I want you to be kind of prepared for bear here. If you don't meet the bear, that's good too. I don't really want you to, but I just want you to be prepared. All the waste you create has to go in the waste jar. None of this is fish friendly, but more importantly, I know this sounds kind of weird, have fun with this lab. All right, people usually kind of enjoy this if you can kind of watch the colors happen, so try to sit back a little bit anyway and relax and enjoy the show. So at this time, I think it's time to watch a video. I'll show you what the QA1 steps look like, how the centrifuge works, how acid and base pH paper works, stuff like that. If you have any questions, of course, let me know. I'm happy to help. Good luck with your lab.